I'll take that. Thank you, my phone.
I was pretty close to it, but I did add it. What initially wrong with it? Oh, no, there's nothing wrong with it. I just restored back on the bio. Don't put password on the bios, so you can't really get into it. Initially, I was gonna flash it, modifying some value, but
Yeah.
And then I was like, okay, I'm gonna try to do something else, but then that's gonna take too much time.
Yeah.
And I was like, oh my god. I was pretty close to that.
How are you doing your training?
I'm really depressed.
Yeah, no, it's just there. It took me a while, I'm not gonna lie.
I mean, right now, all I have to do
And?
is do but the senior knows that.
Oh, yeah.
Yeah, she knows that.
No, we should be able to
And
get,
Brandon knows that.
you should be able to get mastery from seniors, right?
You can get a master's in but categorical.
Oh, yeah, you can, yeah, try to DM her.
Yeah, I'll be DM her ahead of time and just see that over.
Yeah, she can write you something up.
Okay, so yeah. All right, so we're gonna keep talking about Kubernetes. And look at architecture. Probably do a little bit of review here. Can't hurt. All right, let me get my HDI hooked up. So what did we learn about Kubernetes last week, Tyler? It is what?
It's been a while.
What is it?
It's like a.
Uh,
It's a lot of things. That's for sure.
It's basically, so in Docker, we containerize our applications, right? So basically what we do is we get rid of these bloated operating systems that we really don't need, but all we want to do is run an application. Applications we know run in RAM, and basically what containers allow us to do is allow us to get rid of the operating system, run on top of the kernel, and grab only the necessary binaries and dependencies that we need to run that application without the operating system. So essentially, we're just running it off the kernel and nothing else. Okay? So, folks online, do you see the general architecture of a Kubernetes cluster? You can comment in the chat. You guys hear me because you're all muted. Okay, good. All right, so, yeah, okay, good. All right, so this is a multi-node cluster. You can, if you want to experiment with Kubernetes on your own, deploy a single node cluster. It's really not recommended in an enterprise environment, but for testing purposes, go for it. What we're going to do, or what you're going to do in lab, and I'll have the instructions up for you soon, probably tomorrow. I also, just to give you a quick follow-up, I started reading the project proposals. So I had some mental issues because of it, so I had to stop. No, they're just taking a little bit longer than what I thought they would go through, but I do have to speak to some groups about where they're going with their project because their proposals were lacking that information. So, but anywho, hopefully I'll have those done by Wednesday. So we break this cluster up into basically a control plane or what's called the control node, and then of course we have worker nodes. So this is a multi-node cluster, but what it is missing is the server that the control plane runs on. For high availability and for redundancy, you wouldn't just have one server that runs the control plane. Okay, you have multiple servers, so because everything is happening here. Everything that happens with Kubernetes is in this etcd, which is the database, the backend database that basically keeps track of everything that's happening within the cluster. And generally, that's documented in something called a YAML file. Okay, it could be a JSON file, but in most cases, YAML files tend to be a little bit easier to work with. But Kubernetes, at least, but as far as I know, can handle both JSON and YAML files. But really all they are just key value pairs and associations. Okay, so it'll say like, oh, this device is this IP address, or I should say this pod has this IP address. Because pods actually have the IP addresses and not the containers themselves. And one thing you should remember, if you remember anything about Kubernetes, is that Kubernetes does not manage containers. What manages containers? The container engine. So that would be, in our case, it would be Docker, okay? But what Kubernetes manages are the pods, okay? So they are responsible for the containers that are inside of the pods. So abstractively speaking, the pods are what Kubernetes manages, okay? But even that might be oversimplified because the pods themselves are defined by what are called deployments. So you have to have a deployment which deploys the pods, which manages the containers. Okay, so it's a little convoluted, but hopefully it'll make more sense as we move along. All right. So we have this control plane, which is typically the control node or server, and then you have worker nodes or separate servers. Okay, so what I set up, so the way I have the lab set up, is I have it set up basically with this architecture. And you can find this diagram. This came right from the Kubernetes site. In fact, everything I did, everything that I learned about Kubernetes, which took a year and a half, I learned from the Kubernetes documentation. But I did read, because there are a couple books I got too, and I think I mentioned one of the authors that I really liked was Nigel Poulton, who has some pretty good books out on this. But everything that is known about the cluster is done through the control plane, and primarily all the information about a cluster is stored on this etcd backend database. Okay, the API server. So we talked a little bit about APIs and the RESTful protocol, which basically leverages the HTTP commands to basically have you talk to the control plane so that the control plane can talk to the worker nodes. Okay? Or just like anything else, right? You create a configuration. Let's think of it this way. You're making a server and you want to give that server a certain configuration file, right? Where would you store? I mean, you're obviously going to have that config file wherever it needs to be on the system for it to manage the server, right? Because that config file says this is how your server is configured, right? But you have to keep in mind, we don't really have any software that we're configuring. So all we can really do is keep that configuration information on a backend database. And then when we go to deploy, in other words, our deployment, our Kubernetes deployment, that basically gets taken by the API and says, oh, you want to deploy this cluster? Well, I'm going to go to etcd and look at the configuration for that deployment. Because remember, everything is very dynamic when it comes to this. Sometimes it's just like your Docker containers, right? You spin that Docker container up, it does its job, and when it's done doing its job, then it goes back to the exited status. Okay? So these containers basically that are being managed by the pods are not in a persistent state. You can't think of them as being in a persistent state. They come, they go, they shut down, they restart. Okay? So because of that, all right, basically what the API server does, or I should say the CM, I'll go to the CM here. Basically this, etcd is the cluster store, the scheduler. But the control manager basically looks at a cluster and says, what is the desired state? What state should this cluster be in? And then it goes back to etcd and it looks at the database to see what you have configured. So basically what it's doing is it's constantly communicating with the API to say, what's going on with my worker nodes? Then the API comes back and says, this is what's going on with it. And then the control manager says, well, what is the desired state? What do we really want to be happening in our cluster? Let me go check the database and compare that to what the API just told me. And if things sync up the way that they should sync up, then I have my desired state. If something's changed or something's different, then I have to let the API know, and then the API goes to the scheduler and says, hey, something's not right. We need to schedule another deployment with another set of pods with those containers that are part of the pods. Okay? So basically, we have this constant communication that's going on between the worker nodes and the control node to make sure that we always maintain this desired state. All right? So we always have to remember too, this is at some place, somewhere, this is running on hardware. It's not like virtualization where we have a hypervisor that manages everything. With the Kubernetes, basically what we're doing is we're orchestrating the deployment of these containers based on the configuration that exists within etcd. All right? So we have a database here, a YAML file that tells us what should be happening here. So that's the second thing you want to remember. that the database is what tells the control manager what the desired state is. All right? In other words, this is what our cluster should look like. The control manager then communicates with the API to find out if that is, in fact, what our cluster looks like. All right? We also, as a user, okay, you can interface with the API, all right, by using the kubelet. Okay, otherwise, the command kubelet is what runs on the worker nodes. All right, so you might want to think of it. This, I guess, the best analogy I can come up with in my brain is basically we have the Internet Control Message Protocol, but the command we use is ping, right? So ping's the tool, ICMP is the protocol. The kubelet that runs on our worker nodes is the, I guess would be the protocol, but it's the kubectl command that is kind of like the ping. Okay, so kubectl is the command that we use, and kubelet is the software that runs on the worker nodes that allows us to use those commands. Now, as a general rule, two things you want to remember. When you use kubectl, okay, you have to do this as a standard user, all right? This requires, kubectl requires a standard user on your control node and the worker nodes, okay? Kube ADM, there's an E there. Kube ADM typically is going to be done by root, okay? So when you're doing the lab, okay, if you're going to be doing the lab, I've also toyed around with the idea of maybe just going through the steps in class with you guys, but I don't know, we'll see. So Kube ADM always has to be done as root. Kubectl always has to be done as a standard user. All right. I should point out too that you can have a server that could be the control plane server, but it could also be running worker nodes. So you could have you literally could have a single node cluster where you're running Kube ADM and kubelet, both of those applications. Okay, so in the script that I wrote, what I did is I have a script that I wrote called kubectl or setup kube tools sh. You just run it and it'll install everything. Okay, so I try to trim some of the work by writing some scripts for you guys to run, which you'll be able to download from the Git or GitHub. All right. All right, so it's the control manager that monitors the cluster, components, and responds to events. Basically, what it's looking at is the YAML files for the deployments, is what it's looking at. All right, the deployments define the pods. It says these are the pods that should be running. So you're not really looking at the containers per se, you're looking at the pods that are deployed. All right. And you can use a lot of this with a cloud, public cloud, like there's AWS, it has AKS, and then there's Google Cloud Platform that has Google Cloud Kubernetes. And that basically, in this particular case, all you're worried about is this, and then all of this stuff here is on a back-end cloud. You're really just using, so instead of having, if you had a single node cluster on premise, then you would be just working with that, the control manager. But if you're leveraging it or using a cloud provider, then the cloud provider has to talk to the cloud control manager, and it's the cloud control manager that's really going to be talking to your etcd, your backend database. Okay, but there's some added stuff that has to go on if you use a cloud provider because the cloud provider each cloud provider has their own lingo, right? I think like if you're using AWS, then you have a simple storage solution bucket or an SS3 bucket, okay, or you may be running it on an EC2 host, all right, and then I think Google Cloud or is it Cloud or somebody has droplets. Drops? That might be the other one. DigitalOcean, yeah, everything's got a water theme to them. Yeah. So because each cloud provider has its own unique, labels for what a host is or whatever, you have to go through the Cloud Control Manager. Okay. Good. All right. So these are your worker nodes. All these worker nodes will have to have a container engine running on them. Okay, so in our case, you're gonna have Docker installed on here, but you're also gonna have Docker installed on all these worker nodes because it's Docker that actually manages the Docker engine is what's actually going to be managing the containers. So remember, it's the Docker engine that manages the containers. Kubernetes manages the pods where the containers reside. All right, so in this little icon here, you see like these little gears, and you see these little boxes over here. These are basically your containers, and that the gears represent the container engine that's using it. Okay, so, but again, these worker nodes through kubelet, okay, basically talk to the control plane and the API to understand what the pods should be doing, or how many pods should be deployed, and what the deployment specifications are. All right. So it's really kind of crazy. It's really kind of nutty how it works. But I have another slide that might do a better job explaining it. Okay. But basically, your worker nodes communicate through the control plane API via the kubelet software using kubectl type commands. All right, there's a lot of them. In fact, if I were to go to my cluster, I'll stop sharing here for a bit. And cluster. Make sure that I'm sharing the cluster. All right, so there's a help, so you can do kubectl -h. I'll type less because there's going to be a lot of stuff. And you can see these are all the different commands that kubectl uses. So I might look and see, oh, cluster info. Let me do kubectl, and then I'll use get, because get is one of the RESTful APIs. And I'll say, what is it? Cluster info. Okay, and I might want to do less. I'll do less just in case, because I don't know what that's going to show up. So, yeah, I spell something wrong here. Server doesn't have a resource type cluster info. What? kubectl get. All right, well, use help. kubectl get. Okay, that's -h. Let's see, file extensions. All right, now I can do kubectl get node. All right, and you can see that my nodes in the cluster, I have a control node, and I have my 3 worker nodes. Okay, and one of the things that's really important is this version number, because when you create a YAML file, in the YAML file, you will have to put the version number. Does anybody have any thoughts on what that version number is referencing? So remember that the kubectl, or the kubelet software, has its own version number, and it's talking to the API server. So if you think back to Graylog, right? You had Graylog sidecar that had to talk to the Graylog server. It's a lot like that. The only difference is that you have to make sure that whatever kubelet version you're running is compatible with the API version. Because if they're not right, then they're going to have some problems. So just to give you a quick example here, if I go into my, let's see, where I put that YAML file. So if I go into my YAML, I have my YAML there. I guess what I'll do is go into Kubernetes documentation. And we'll look at okay, so good. Here's the YAML file, right? See API version right here. This is really important, okay? Now, one thing you got to be aware of with Kubernetes is that there's a new release every 3 months, okay? This is why I've been having such a hard time writing up the lab instructions, because they keep changing shit on me. So, but anyway, and sometimes I've gone into the documentation here, and the stuff in here is wrong. So it was been really challenging. I don't want you to feel sorry for me, but a little sympathy or a little empathy wouldn't hurt. But anyway, when you apply your deployment as a YAML file, you want to pay particular attention to the version number and make sure that version number will work with the kubectl version that you're running. The one thing I would caution you is if you do like API version 1, it's usually, you're pretty safe if you go back and you look at this version here where it says v1 and then .23.5. So as long as the kubelet version is v1, and you go to the YAML file, and you see in the YAML file that you're running version 1, that's good. You usually won't have any problems. And a lot of times, you won't be building these YAML files from scratch. You'll be getting them from somewhere. All right? It's kind of like the equivalent of Docker, where you did like the Docker file. Now, you made that from scratch, but you can easily get those Docker files from somewhere else. Okay? But you need to make sure that that version number doesn't say like beta. Like you'll see v1, beta 1, v1, beta 2. I would stay clear of that because this is where I ran into problems. Is I would get like a YAML file with a beta version, and commands that I would use with kubectl wouldn't work with the beta version. All right, so definitely pay attention to any YAML files that you get, and then you'll look. Everything in Kubernetes is defined by objects. The most, I don't know how to say this. I'm going to say the most, the smallest object, I guess that would be a good way to put it, would be the pod. Okay, I would say that. Maybe I'll rephrase it this way. The pod is the closest Kubernetes object to the container. Okay, and so really it's the pod that defines what we want from our containers. Okay, so but here if you look under kind is what tells you what the object is. So this API file or this YAML file isn't defining a pod, it's defining a deployment. The deployment is another object. Deployments are what allow you to do replica sets. Or I should say, they allow you to do replication. All right. They also allow you to do upgrades, and things like that, right? Now the funny thing is that a replica set is another object. So it gets really crazy because what happens is, probably if I draw this might be a better person. Let me make sure the folks can see do this. Yes, I just have to do this, and then draw it up here. So we have a pod. And in the pod, okay, you can have, I don't know how I should draw a container. I'll just make it like a box. Okay? So in the pod, we can have one container. As a general practice, we usually have one container per pod. But you could actually have multiple containers within a pod. And you can even have a volume, a storage volume within a pod. Right? But generally, if I were to define, let's say, the IP address for this pod, I might have like IP address ... and then like an IP address of some kind. All right, I'm just making that up. But this is, and that's just one of the properties of a pod is the IP address. All right. Then outside of this pod, what we end up with is the deployment. Okay, and the deployment is what allows us to do replication or upgrades. Okay, and there's other things that we can do. So the pod itself, this pod right here, is a Kubernetes object. This deployment is another Kubernetes object, for which basically deployments allow us to do replication, but we do replication through what's called a replica set, which is another object. So there's a lot of objects within Kubernetes. So maybe this will make a little bit more sense if I go back to my deployment. Go back to here. And make sure I'm sharing this. Okay, so if you remember when we were back in on the Kubernetes site, right? So what I can do is create. So if I go to kubectl create, all right, that gives me another list of different things that I can create. And one of the things I can create is a deployment. So what I did is I created this deployment. All right. So it might be hard to read, but it's cube. I think I have an extra C in there. Create deployment, and then I tell it what image I want to create. So let me fix that. That's like an E. Yeah, it's an E on my computer. It's hard to read on that screen. Okay. So I've already got this deployment. All right. So if I do kubectl at all, right, this gives me a little bit more detail. So it tells me I've got a pod here running BusyBox. I got a pod here running this new Nginx deployment, and another pod here running another Nginx deployment. All right. And if I wanted to, I could do like kubectl delete, and I can do. So you can see right now, this replica set .apps new Nginx sped up for 42 minutes. Okay, so I'll demonstrate deleting that. So let's see, deployment apps new Nginx IND. I got the end of your history somewhere. Oh, there it is. Okay, but yeah. So I can do creative. Where's the delete? delete earlier thing. There it is. But I don't want, yeah, 9D. All right. So I can delete this deployment. Let's say I accidentally delete it. And I'm doing it for demonstration purposes purposefully, but let's just say that the deployment somehow gets screwed up. So I can delete it. It shows that it was deleted, right? But because of what I have in Etsy, because I'm only doing this on the worker node. I'm not doing it on the server, right? So, well, I'm doing it for the worker node, but then the server is smart enough to know, wait a minute, that's in my database. So the control manager says, no, you shouldn't be deleting that deployment. So now when I go back here, you can see that the deployment is back and it's 26 seconds old. All right. That's because in my config file that's sitting in etcd, I have a defined desired state, and that desired state says that this pod should be deployed, and it shouldn't go away. So even though this deployment object has within it the pod object, if I delete this deployment, the pod goes with it. But because I have a defined replica set that says, no, if that pod goes away, replicate it back in etcd in my database, the control manager says, no, this should still be there. So it spawns another one, it creates another one. Just like that. That's how quickly it happens. So that gives you a sense of how important etcd is and how important it is for the worker nodes to communicate with the control node through the API interface. Okay? All right. That's a lot. All right. Let's go back to this. And let's go back to show you guys. All right. So kubelet is basically what is running on the worker nodes. There's also a kube proxy, which in most cases, what the kube proxy does is it acts as the network piece of what the worker node should be doing. It's kind of like the person that just handles the network part of it. Okay. Although I read somewhere too that it does other things. All right, but for our purposes, generally we're going to be looking at the proxy from a network perspective. So this is kind of what I drew up on the board. All right. Basically, these deployments are what allow applications to be replicated, and this drills down into what the server is actually doing. Okay. So this is where that kube proxy comes into play. For the most part, we're going to be using RESTful type commands. So you saw I use kubectl get all, and that got me all the information about my deployments. All right. But in the control node, generally what's going to happen is on the back end, you're using these curl-like commands. And if you remember from last week, curl is client URL. That's the command that really gets used. So kubectl is really doing a curl get or a curl post or a curl delete. That's really what's happening behind the scenes. So if you don't have the kube proxy, then it doesn't have basically the intelligence to know if somebody types a curl-like command. So I did say that it's primarily used for networking, but kubelet, okay, is the software that allows us to use the kubectl command. But when we really issue this kubectl command, behind the scenes on the back end, we're really doing curl, okay? And the kubectl basically takes care of whatever it is we're trying to do. So instead of, if I do kubectl get all, that's really a curl command that's pointing to some location on the server where the database is stored and getting that information from the database. So if I did the curl command, I'd actually have to type out the path of where the database is, the host that it's on, and all that other garbage. All right? I could, even if I knew how to do that with the curl command, I would still need the curl proxy to say, this command is really meant for the Kubernetes API is really what it's meant for. So that's really what the proxy does. Now, more times than not, when you're trying to do networking stuff, you use the curl command to issue like those networking type commands, because really you're just issuing a curl and then an IP address and then something having to do with layer 3. So it cuts out the application layer stuff. All right, but basically this kubectl command, when you install kubelet on a host, whether it's the controller node or a worker node, it creates this. This should be /.kubeconfig. That dot should be there. So any computer, this is why you have to create a standard user. You can't create and you can't have .kubeconfig in the root directory. It can't be in root. It's got to be home user, and then in that user, it's a hidden directory, and then the config. All right. So let me show you what that looks like. So here's before I do that, there's an example of using the curl command to get the certs. Okay. So if I wanted to join a worker node to this cluster, that's how I would use the curl command. I would tell curl to get the cert for that user, get the key for the certs, and then find it in root, blah, 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 and then on that controller with that port and the API version 1. Instead of just doing kubectl join. Basically, join is that command right there. Okay, that's what it is. And then it creates a token, and that token is what contains all the certs and everything that's needed for any workers to join that cluster. So we'll take a quick look at that and see what that looks like. So let me go back to, I think I showed you guys this, but just to get in the right context, we'll take a peek at it again. All right. Damn it, Zoom. Okay, there we go. All right. So let me get to my home directory. All right. Here it is. Okay. So we're in there right now. Home student. So I do ls-la, and there is the .cube. So if I cd into .cube, I will see the config. There's the config. And if I cat that config, there are the certs. Okay? So, and you can do kubectl config view, and you get the abridged version. And this is really what's important. Okay? And this is really the YAML file that creates the config for etcd. All right, so you can see that, and the indentation's important, and these little lines are important. Basically, the YAML file, these little lines indicate that this is an array. All right, and then so I have my version, then I have my cluster object. Right? Within the clusters object, I have a single cluster. All right, and then these are the certificates. This is the default name. You can create your own names. I just went with the default Kubernetes names. And then I have the context. This basically is a Kubernetes cluster, again, default. And then there's a Kubernetes admin, default. All right, and then this name. And basically, it looks a lot like what? The UPN of a Kerberos route. It's the same kind of thing. Remember with the Kerberos principles, we had the principal name and then an instance and then the route. That's essentially what we have here. We have our name or our cluster name, which is Kubernetes, followed by the user, right? So that's basically our instant or our principal, and that's our instance. The only difference is here we have a hyphen, okay? But that basically tells me who the user is, and then at, and then the name, or the cluster. So you can almost think of the cluster as the domain, and then the user is being part of that domain. Or maybe a better analogy might be a host that belongs to a domain. Here we have a user that belongs to a cluster. Okay? Okay, and then look at the kind. You see kind again, right? And that tells us that this is a config. A configuration for one object, a cluster. Okay? A single cluster within a group of clusters. Okay? And then again, users, that's another object that's part of this config, which is part of this cluster. So if I had a second cluster in here, I have another line, and then all my clusters would be part of one array. Okay? And then the properties of those clusters get nested within the array. All right? So let me get down to here, and the thing about these certs is you see the certs are really not tied to the user. Because you can see here that they're redacted, okay? Because the certs really are tied to, what do you think? It's not going to really be a user. What is the cert tied to? Yes, but we don't really have users, right? We don't have users that we associate to in the cluster. What do we really have in our cluster? The nodes, the individual nodes, right? So we can't expect somebody to go, oh, I'm going to log in to this node and I'm going to deploy this pod, right? Because we want Kubernetes to do that. We want Kubernetes to manage it. So when we build our configuration, just to be clear, yes, it is within a standard user's directory, but it's not the user's directory, it's the Kubernetes configuration, okay? We have to have a user so that we can create a home directory. It sounds kind of weird, right? But really the only reason we create, there's two reasons why we create the standard user in Kubernetes. One is so that we can run the kubectl command, and the other is so that we can have a home directory to put our configuration in. All right, that's really the only reason. Because if we don't have, at least on Linux systems, you don't have /home, right? You have /root. So Kubernetes is looking for /home some user .q config. That's where Kubernetes is looking. So if we did it on root, and you did root.q, Kubernetes wouldn't find it. It needs to find it in home, some user, in our case student, and then the .config. That's where it's looking. It's actually using the $home environment variable to find .q. That's what it's doing. Okay? So in Linux, that would